Hi everyone, today we're going to start 8.2, which is use properties of parallelograms. A parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. If you look down here, we see this symbol. This symbol stands for parallelogram. So instead of writing out parallelogram, you can just write this symbol instead. So if we know something is a parallelogram, that means that we know that the opposite sides are parallel. So in our example, that's what those arrows mean. So that means that PQ is parallel to SR, and we know that QR is parallel to PS. Properties of parallelograms. Make sure you write this out in your notes. So number one, we know that the opposite sides are congruent. So that would mean that PQ is the same length as SR and QR is the same length as PS. Number two, opposite angles are congruent. So that would mean that Q is congruent to angle S and angle P is congruent to angle R. Number three, the consecutive angles are supplementary. Consecutive angles would be this angle pair right here. If you look, we notice that angle Q is obtuse and angle P is acute, meaning they're not the same. But what we do know about them is that they're supplementary. What does supplementary mean? It means that they add up to 180. So angle X plus angle Y is equal to 180. And lastly, number four, we know that the diagonals in a parallelogram bisect each other. What does bisect mean? It means cut in half. So if point M is the point of collision of our two diagonals, that means that QM is the same length as SM and PM is the same length as RM. Find the values of X and Y. So we want to use our properties to solve for these variables. So let's start with X. If I look at X, I notice that it's on segment AB. And for a parallelogram, we know that our opposite sides are congruent. So the opposite side of AB would be DC. So we need to set an equation equal to each other of X plus 4 is equal to 12. So I'm going to subtract 4 from each side. We end up getting that X is equal to 8. Next, let's look at Y. Well, we notice that Y is an angle measure, and it's here. We know in a parallelogram that our opposite angles are congruent, and the opposite angle would be angle C. And if you look at the diagram, it says it's 65 degrees, so there's no math that we have to do here. It's just Y is equal to 65. Find FG and then find the measure of angle G, the measure of angle H, and the measure of angle F. All right, so let's start with FG. FG would be here. So looking at our diagram, what is the length of FG? Well, it would have to be 8, right? Because the opposite sides are congruent, and if HE is 8, FG also has to be 8. Now let's look at our angles. Angle G is right here. Which angle is opposite of angle G? It'd be angle E. So that means that angle G is 60 degrees. Now let's find the measure of angle H and F. What do we know about angle H and angle E? Well, we know that they're supplementary. So if I call HX, angle HX, I then know that X plus 60 is going to equal 180. Subtract 60 from each side, I end up getting that X is equal to 120. So H is 120. So what is the measure of angle F? Well, angle F would also have to be 120 because they're opposite angles of each other. Find the values of x and y. Let's do this again. Let's start with x, and we notice that x is an angle measure this time. So the opposite angles are congruent, meaning that 2x is equal to 50. Divide by 2, x is equal to 25. Now let's solve for y. Well, we know that the opposite sides are congruent in a parallelogram. So 18 is equal to y plus 3. Subtract 3 from each side. 15 is equal to y. For our next example here, we have diagonals. And we know that the diagonals in a parallelogram bisect each other. So if I want to solve for h, what am I going to set equal to h minus 8? It would be those two segments, so 12. We know that h minus 8 is equal to 12. I'm going to add 8 to each side. h is equal to 20. All right, next let's solve for g. So if g plus 7, which segment am I going to say equal to g plus 7? It's going to be 15. So g plus 7 is equal to 15. Subtract 7 from each side. We end up getting that g is equal to h. Next, we're going to do a few word problems. So for A, the measure of one interior angle of a parallelogram is twice the measure of another angle. Find the measure of each angle. I'm going to pause the video so I can sketch out a parallelogram. So with a parallelogram, we're going to have obtuse angles and acute angles. So if one of the interior angles of a parallelogram is twice the measure of another angle, twice as much, we know we're going to use multiplication. So if the small angle is x, the obtuse angle is twice as much, that would be written as 2x. All right, so now I have these angles. What do I know about this angle pair? Well, I know that they're supplementary, so they add up to 180. So I have 2x plus x is equal to 180. Let's combine like terms. 3x is equal to 180. So we end up getting that x is equal to 60. So that means that this angle here is 60. If I plug in 2 times 60, that means the obtuse angle is 120. And this matches my situation because it tells us that one angle is twice the measure of the other angle, and 120 is double 60. Now let's move on to B. The measure of one interior angle of a parallelogram is 30 degrees more than the measure of another angle. Find the measure of each angle. Once again, I'm going to pause this and draw out my parallelogram. All right, so this time we are told that one interior angle is 30 degrees more than the measure of another angle. So 30 degrees more gives you a hint that we're going to be using addition, plus 30. So if my small angle, once again, I'm going to call that x, that means that the large angle is going to be x plus 30. Well, what do we know about those two angles? We know that they're supplementary. So I'm going to add those equations up, set them equal to 180. So x plus 30 is equal to 180. Combine your like terms. 2x plus 30 is equal to 180. Subtract 30 from each side. 2x is equal to 150. Divide by 2. X is equal to 75. So we have x is equal to 75. So 75 plus 30, that gives us 105. And we're done. The last problem for today, we're going to do a proof. So we want to complete the proof. We're given that ABCD is a parallelogram. We want to prove that triangle ABD is congruent to triangle CDB. All right, so once again, our statement and reasons, we want to fill this in. So the first statement is that ABCD is a parallelogram. So what is the reason for that? It would be given. They told us that here. Statement 2 is missing, but we know that the reason is that the opposite sides of a parallelogram are congruent. So looking at this parallelogram, what two sides are congruent? We'll start with BA and CD. So BA is congruent to CD. Statement 3 is also missing, but our reason, once again, is that the opposite sides are congruent. So what other two sides are congruent here? We know BC and AD. So BC is congruent to AD. Next, we know that the statement that angle A is congruent to angle C. So I'll mark that. Angle A is congruent to angle C. What's my reasoning there? Well, since this is a parallelogram, we know that the opposite angles are congruent. So now looking at my two triangles, triangle ABD and triangle CBD, we do have enough information to prove that those two triangles are congruent. Which congruent postulate is the reason? Well, it would be side, angle, side. And we've completed the proof.